In this video, we're going to go over the annuity formulas. So we're going to see how to solve for the future value of an ordinary annuity using the annuity formula. Right? So in this problem, we have 4 different payment methods for your graduate school, all nominally costing $15,000, but we want to find out what is the future value of these payments. So we're going to focus on C and D, which is an ordinary annuity, and D is an annuity due, right? So let's solve for part C first. So part C, this is a payment of 3 payments of 5,000. So time period 1, 2, and 3. It's an ordinary annuity because the payments are made at the end of each period with an interest rate of 2%. Right, to find the future value at time period 3 for these payments. So we'll solve for them separately. If we solve for them separately, then this 5,000, this doesn't earn any interest because we're moving from time period 3 to time period 3. So this is just 5,000. This 5,000 over here, this moves from time period 2 to time period 3. So that's 1 period over. So it gets interest once. So 1.02. So it's 5,100. And finally, this one gets interest from time period 1 to 2, and then from 2 to 3. So that's 2. So 5,000 times 1.02 to the power 2, that's 5,202. Add them up, you get 15,302. Right? So this way you can solve for each of the payments separately. It's a good way to find out exactly how much the future value for each one of them are. But if you were solving for this for more than 3 periods, like if this was for 50 time period and there's a payment of $5,000, make 50 times over to solve for this, like each one of them separately would be quite tedious. Right? So an easier way of solving for this is to use the annuity formula. So that way you can do all of them in one formula very quickly. So let's look over the future value of an ordinary annuity, right? So the formula is equal to your payment. So payment is the recurring amount. So in this case, the $5,000 times 1 plus I to the power n. Remember this n over here, this is the number of payments. So we have 1, 2, and 3 payments. So this indicates the number of payments, right? Don't confuse it with the time period. This is how many payments there are. So there are 3. Take the whole thing, subtract 1, right? And then this entire thing over I. Okay, so let's solve for this. So this is future value of the annuity at time period 3 is equal to payment, which is 5,000 times 1 plus I to the power n, so 1.02 to the power 3 minus 1 over I, which is 0.02. Okay. So that's your formula. So when you're showing your work, this is what you would need to show: 5,000 times 1.03 or 02 to the power 3 minus 1 over 0.02. When you're solving for this, my advice is to start from here. Solve for this first, subtract 1, divide 0.02 third, and then multiply by 5,000. So if you're solving for this, let's try it together. So it's 1.02 to the power 3, so that's 1.06 minus 1.061208, and then divided by 0.02, this part, so that leaves us with 3.06, and then finally multiplying with 5,000 times 5,000 is equal to 15,302, right? So it's the same answer that we got here, right? And then for the second part, when you're solving for D, which is the future value of an annuity due, right? You don't have to solve for all of this again. So when you have, now we have 0, 1, 2, 3, 5,000 paid at the beginning of each term, 2%, 5,000, and then 5,000. Okay. Once you have solved for a future value of an ordinary annuity, to find the future value of due is just equal to future value of the ordinary times 1 plus I. Okay. So in this case, future value is equal to 15,302 times 1.02. So that'll give you 15,608. And that's it. Okay. If you have already shown your work for an ordinary annuity, if you have already solved for the ordinary annuity, then you can just take that work, multiply it with 1 plus I. That gives you your annuity due. Right? So there you go. So we have solved for the future value of an ordinary annuity using the formula, and then we have solved for the future value of an annuity due using the formula and then multiplying with 1 plus I.